In this video, we will see which are the different operations that can be possible by using the stack. There are different operations possible on the stack and we will start them study one by one. Before going to actually these operations, we will first of all see what is the structure or what is the data structure of a stack. We all know that stack is nothing but a deck of memory places and in which there is a one top that is pointing to the current position of the stack, and in that you have to only put the data. So like the linked list data structure, we can also write the stack's basic data structure, or we can write as a node structure of a stack. So what is the data structure of stack? That is nothing but the title, struct, stack in bracket. You have to specify only two members for this structure, and that is nothing but the integer data of size max, means how many elements you want to insert in the stack or handle using the stack, and nothing but the integer top, and that is the pointer pointing to the current position of the stack. Then after completing it, you have to create one variable of the type okay. So what does this actually stack mechanism displays us? Initially, the top is set to -1, means what is the initial value of t? That is nothing but the -1. Then a stack with top as -1 is known as an empty stack. So how to identify the stack is empty or full? When its top is -1, stack is empty, and when its value become max -1. What is your maximum values in the stack max, and when you will reach as the max -1 positions, then at that time you can say like stack is a full. There are another different operations on the stack, that is for example push and pop. Push is nothing but the inserting the element into the stack, and pop means the deleting the elements from the stack. For doing the push operation means you have to carry the stack from its previous position to next position. For example, here are two elements were inserted previously. You have to insert third element. But you all know that top always points to the current position of the stack elements, means where the data is inserted. So to insert the new elements into the next position, you have to shift to the next position. So for the push operation, you have to make the top plus one position, means you have to shift it to the next position. But the means in this case track is growing towards the upper, but the pop operation is reverse of the push operation, because when for example there are some elements in the stack and you have to delete the elements from the stack, then in such a mechanism, first of all the top is pointing here, you will remove this from the position, means 5 is deleted. Then you have to take the top -1 position, means to the lower position, because it will point to the next element of the stack. Then in this case stack is shrinking. In the pop operation stack is shrinking, and in the push operation stack is growing. Okay, so these are some basic mechanism or different operations based on the stack. Now we will see what is the actual coding part while performing such operations, or which are the different functions for these mechanisms. We will see them one by one. Now first of all we will see the function or a programming part that we have to use for the initialization. We all know that initialize is nothing but a function that is used to make stack empty. Means when you have to start from a new again, then you have to make sure that the stack is empty or not. For that, the initialize function will be like void initialize. As it is not returning any value, its return type is void. Then you have to pass the variable of a stack data structure, that is the stack star is. Then the simply procedure for you remains for this function is that you have to make the stack empty, means you have to make the top minus 1, means s pointer top equals to minus 1. So this is the functional mechanism for initializing the stack empty. Now when you are performing any operations on a stack, or while using any operations, or while performing any operations, there may be sudden requirement like you have to check first. Here we are forcefully making the top minus 1, means we are making the stack empty. But there can be some cases like we have to check whether the stack is empty or not, and then accordingly we have to perform the operations like insert or delete, means push or pop. Then in such cases we have to use the empty, means initialization is forcefully making the stack empty, and empty is the operation that checks whether the stack is empty or not. For that, it is returning some value for the conclusion. So its return type is integer. Empty is the function name. We will pass here like a previous initialize function stack type star is variable of the stack. Now how to check whether the stack is empty or not? In the previous initialization function, we have seen that when s pointer top equals to minus 1, means we are making stack empty. Means when top at the minus 1 position, it will indicate the emptiness of a stack. So here we are only checking it against the if condition. Means if s pointer top is equal to minus 1. When it is minus 1, then our stack is empty, means we will return 1. Otherwise, we will return 0. Means what? This is the returning 1 means stack is empty. Otherwise, if it is not minus 1, it returns 0 means the stack is not empty. It is at a full condition. Okay. Then, what is the next operation on the stack? That is the likewise we are checking the emptiness of a stack. We will check the fullness of a stack. We will check whether the stack is full or not. We know that when top is at the minus 1 position, it is empty, and when top is at the max minus 1 position, it is at a full condition. So in this we have to simply check whether it is at the max minus 1 position or not. Here we will simply change the function name integer full stack star is. We are checking here if stack pointer top is equal to, we have to simply change the condition like whether it is a max minus 1. If it is true, it will return minus 1, and if it is false, when it is true, it will return the 1, and when it is at the false state, then it is returning the 0. Means when you are having the 5 elements, okay, max size is 5, and when you are at the max minus 1 position means 4, then the stack is full, and when the top is at the minus 1 position, then stack is at the empty position. So these are the some functions related to stack emptiness and fullness. Now the next two functions important from our programming point of view, that are the insertion and deletion. In the previous video I have told you that the push is related to insert and pop is related to delete. Okay, so keep in your mind that there is a push operation for insertion and pop operation for the deletion. Now how to push? Pushing is nothing but the making the top advance to the one position and then inserting data element in it. So how to complete this task. For example, while push in bracket, you have to take the stack variable. Now, in this parameter list, you have to add one parameter extra, that is the element which you have to push into the stack, that will be taken here, like integer x. Okay. Now, what is the actual next procedure? In this procedure, simply advance top to the one position next, that is s pointer top will be advanced to s pointer top equals to s pointer top plus 1. In the push function, we have seen these things. Now we have to only apply it here. S pointer top equals to s pointer top plus 1. What is the actual demonstration of it? If top is here, after performing this operation, top will be shifted to here. Means it will at a position where it have to accept the data to insert into the stack. Now we have advanced to the next position where we have to insert the element. The only task remain for us is that we have to only push the data. But how to push the data? The data is stored into the s pointer data variable. But s pointer data having the pointer where the top is situated. So we have to write like s pointer data equals data of s pointer top equals to x. Okay, and we are completing the push function. So after following such statements, we are able to easily insert into the stack. Now the last function remain for the stack or the operation, that is nothing but the pop. What is the pop? Deleting the elements from the stack is nothing but the pop. How to perform it? Simply, there is no need of any variable like the push, because we have to only delete from the previously inserted stack. So here it is a while pop. Now, simply the procedure changes slightly here then. When we are deleting any element from the stack, for example 1, 2, 3, then there will be a one variable which will store the deleted value and display it later that this value is deleted for the demonstration. Now, what is the actual procedure? We will accept one variable like integer x. One question in your mind will arise like, can we accept only integer type data elements into the stack? No, we can accept the string elements also, but we cannot accept the floating point numbers with the help of a stack. This is the one restriction. Now, we are creating the integer type x variable for accepting the data of the deleted pop, deleted stack. For example, how we carry out the data from the stack? Like we have inserted the data into the stack like. The data inserted like s pointer data of s pointer top equals to 1. Likewise, we have to only reverse this case. Means by this case, this x will be inserted into this. If we change the condition like x equals to s pointer data of s pointer top, then it will take out this data from x, means it will popping the data from x. Then we have to only -1 top, means s pointer top equals to s pointer top minus 1. Okay, and then we will simply return the x. Okay, so after performing such steps, we can easily delete any data from the stack. Now the last, again one last function or operation remain regarding the stack, and that is nothing but the how to display the different elements of the stack. Okay, what is the display? For that, we will simply take the integer type display top function, then pass here the stack type variable star s, and here we are checking if not empty stack. This is necessary condition because if stack is empty, there is no any chance to print any element of the stack. When this condition false, then we are able to print the data element. If this is false, then we will return the data elements like s pointer data of s pointer top. Okay. Otherwise, we will return the -1 position. Means there is no any data to print. And this is the completion of the display function. So these are the different functions or operations regarding the stack. Means while solving any problem related to stack, means with using the stack, we have to compulsorily follow all these different operations, and with the help of these operations we can only insert or perform any actions on that program or that problem statement. The next different types related to stack, that are the different stack expressions, then how to evaluate the postfix expression, we will see in some other videos. Thank you so much.